Welcome to IP Solutions Tech Talk. This part of the show we're going to discuss software-defined networking, and with me to do that I have Anders Krus from VMware. Anders, there's a lot of different providers with SDN out there. What distinguishes VMware's offer?
Well, yes, that's true. Software-defined networking, SDN, doesn't mean one and the same thing to all the vendors in the business. It means a little bit different things depending on the approach you have to networking.
Okay.
Yeah.
So what is kind of the unique selling point for VMware?
For VMware, when we say SDN, we mean SDN by overlay, and we mean building network and network logic into the hypervisor virtualized environment.
Okay.
Yeah.
So this is kind of the difference if you have like with OpenFlow, when you have like new hardware, control protocol, you have a completely new kind of backbone, new network equipment, everything.
Yeah, that is also SDN, but the SDN for the physical network. We do SDN for the virtualized environment.
Okay.
Yeah. Okay.
So you have anything to show me here?
I do. Let's have a look. So SDN and our product NSX means that we add network functionality into our hypervisor environment, the vSphere environment. And this means that we add the capability of building switching, routing, firewalling, and load balancing right into the hypervisor of vSphere. So I think this picture pretty much shows what this is all about. Imagine that we have two hosts in this picture running a number of VMs. The VMs communicate with each other, but instead of having to trust on the physical network to create the services that these VMs consume, we instead build that functionality right away into the hypervisor. The physical network is still around. The physical network will still push the traffic, but the traffic that hits the physical network will be encapsulated by an encapsulation protocol. In this release, it's VXLAN, but it could be any encapsulation protocol. So if we have two VMs talking directly on the same broadcast domain, then we do a layer 2 stretch over the physical network. If the VMs are on different broadcast domains, then we could do routing in between them. And if we need any type of security, we can provide firewalling in between the VMs.
Okay, so let me get this straight. You have the same physical network that you had before, just that you, with the hypervisors, set up this overlay with tunnels, right?
Yes, so this means that the physical network is agnostic to us. We don't care actually what the physical network is designed, how it is designed, as long as it can provide IP connectivity between the hypervisors of your network. It could be a physical stretched layer 2 network, it could be a layer 3 routed network, or it could be whatever, as long as the performance is there.
Okay, let's go back.
Yeah. Okay, anyway, as long as we need networking to be consumed by the VMs, let's create that functionality into the hypervisor, because this means that the VMs can move around not only between different hosts, it can also move around between different data centers and actually also into a public cloud with the network and with the security settings. So the VM can move around, you can load balance or load share between data centers and between your private data center and a public data center. The VM will move around, including its network components and including the security. So you don't have to build a replica of your physical network everywhere. It's just enough that you have IP connectivity.
Okay, so by having this IP connectivity between your data centers or to even also a cloud provider, that means that you could actually stretch it out, and you need to terminate. You need to have one way to terminate those VXLAN tunnels, right?
Yes.
On the other side.
Yes, correct. So this means that if you have any type of physical workload, or you would like to connect your overlay VXLAN based network to physical network, that has to be done somewhere, and this is referred to as a VTAP, a VXLAN tunnel endpoint. And this can be done either by us, VMware. We have a software component that is included into the product, so you can do it in software, or you can turn to any of the certified partners that can do this in hardware. So either you do it in hardware or you do it in software. Which one you choose a little bit depends on the use case.
Okay, So this is when you kind of bridge from the virtual world to the physical world.
Yes.
So, and you kind of maybe your legacy environment, you can bridge that into your virtual environment.
Yes, the NSX product can build virtual networks on top of any physical network with any design, but still there is an entry point where the virtual networks are connecting to physical networks. So the edge of your data center.
Okay.
And that would be this picture.
Okay.
Okay, cool. So anyway, the endpoint, the endpoint end goal is to be pool-based, meaning that we are creating virtual machines. We can create storage for those virtual machines, and we can create networking for those virtual machines. And that should be pool-based. There shouldn't be any touching within the physical network, nor the storage, nor the physical compute hosts when we create a new VM. Everything should be automized, and we could move the VMs around, which gives us incredible flexibility when it comes to automating things, but also application continuity and disaster recovery, meaning that things can move around, data centers can even go down entirely. We just move the VMs, including, again, the networking and the security, into another data center, a backup data center, disaster recovery data center, or in the public cloud.
Okay, so compared to before, you had really good control over your virtualization, and the storage is also being kind of good progression.
Yes.
But networking has been on the physical side. You have been.
It's the final step in the virtualization of the data center.
So you don't have to rely on predefined VLANs in switches and things like that, and that the data centers have exactly the same VLAN design and such things.
Yes, and that's what this is all about.
Okay. Well, thank you. This was the first clip of 2. We're going to discuss this even in more detail in the next one with Anders, and we're going to go into real technicalities. So see you there. Bye.